Vector databases are, as they say, so hot right now. And I got Ken Krugler back on the show today to talk about vector databases and Apache Pinot and kind of a bunch of other things that come up in conversation, as happens when Ken and I talk. Let's listen in. Welcome to another episode of the Real-Time Analytics Podcast. I am your host, Tim Berglund, joining you here in the StarTree studio. And I am pleased to welcome back as my guest, Ken Krugler. Ken is a longtime presence in what we have traditionally called the big data space, pillar of the Pinot community, returning guest to the Real-Time Analytics Podcast, the triumph of hope over experience, as I like to say. Ken, welcome back.
Thank you. Thank you. You know what this reminds me of? I don't know if you've ever seen First We Feast, like the hot wings thing, where there's a guy who interviews people, not like me, like actual celebrities, but as part of the interview process, they eat chicken wings with progressively hotter hot sauce on them.
Yeah.
Like it starts off at 1,600 Scoville units or whatever it is.
Yeah.
And the last one is like 1 million plus. Anyway, I actually enjoy it because when you are dying from like hot sauce, you actually see the person as they really are versus the persona they project, during usual interviews.
There you go.
It's really,
there you go.
So that's my idea for your next, podcast.
Okay. Actually impose pain on the guest. You're going to be the guest.
Okay. Thank you.
We were talking about hot sauce here at StarTree yesterday. So,
okay. So what do you want to talk about?
I want to talk about the thing you want to talk about, which is vector search, generative AI.
Okay.
I mean, why not? We need to figure out a way to bring these.
All the cool kids are doing it.
And frankly, if there's a distribution and you've got like cool on this side of the bell curve, you're pretty far down into the sort of kid I was in middle school at this point. It's not just the cool kids.
Yes.
Kind of everybody.
Lots of people are talking about it. I know when I go to my coffee shop in the morning and people are asking me about it, I know it's it's in the general consciousness.
Yes. And then you live in Eastern California. You're not in the Bay Area. This is not like,
I'm not in the Bay Area. I'm in the foothills of the Sierras. Yeah. It's not like I'm surrounded by techies. My dental hygienist asked me, she was at the coffee shop and she's like, what about this ChatGPT thing?
Right.
So,
and, there are booms and there are busts and we're no stranger to those.
Right.
There's
However,
so
I had an experience with ChatGPT. Everybody's talking about it. So I signed up. I paid the money to get access to ChatGPT 4. And I'm sitting in the coffee shop and I'm like, I need to give it a test here. Like, I really want to try and exercise it. What's some obscure text that I can say, hey, summarize this in different voices?
Okay.
And this woman working at the coffee shop, who I know, Molly, she's great. She's like, well, there's this thing called the Tractatus Logico-Philosophicus, which is like this famous paper from 1918 or something, written by an Austrian, very obscure, but very foundational if you're into philosophy. I knew nothing about it. So I'm like, okay, hey, ChatGPT, summarize this. And I had to try a couple different voices. Summarize it to a Southern California surfer dude. Summarize it for a Jesuit priest. Because I had a friend visiting who really reminded me of a Jesuit priest. And it was that last one. Go ahead.
I was just going to say, I don't know if you gave me several summaries, if I could pick the one that was the Jesuit priest. Like I might know it wasn't a Southern California surfer dude, but I don't know the Jesuit priest voice.
Right.
It's okay if I don't. That's an odd choice, but.
Right. Well, I thought that was an interesting one, and that gave me the most interesting response.
Okay.
Okay, because it said, however, the last proposition of this paper, whereof one cannot speak, thereof one must be silent. Like there's this thing that says there are limits to what you can describe with words. And if you can't describe something with words, you shouldn't be talking about it.
Don't do it. Yeah.
Right. Don't do it. The surfer one was like, so just zip it, dude. Like that was how they were describing it. But to the Jesuit priest, it said, okay, and here's the key thing. It said, though it may seem counterintuitive, this perspective can lead us to a deeper respect for the mysteries of our faith, reminding us that God's nature is ultimately beyond our full comprehension And there are realms of our existence that remain sacred, silent, and beautifully mysterious.
I will sign that without mental reservation, actually.
Right. Wow. And I'm like, okay, that last bit, that was really meaningful. And like, it felt like deep.
Mm-hmm.
So I'm like, it had to get it from somewhere. So I searched Google, Bing on that last phrase.
Yep.
0 hits.
Okay.
Like that was
synthesized.
That was its creation.
Yeah. Generated, as it were.
Right. And way better than anything I could have ever written.
Yeah.
Like I could not write that last sentence. So I'm like, okay,
it got your attention.
This is real. This is like, yes, there will be hype, but it's real. Now, what's interesting is I'd actually gotten involved with sort of this technology back in 2017 or so, because I was dealing with the problem of kind of fuzzy search, semantic search. How do you find things that are related but not keyword? Right? How do you do things that isn't keyword search?
And there's the whole semantic ontology approach to that, right?
There is. I was looking for something I could apply big data principles to at scale in a simple manner.
Okay.
So first I looked at, Google has this thing called word to vec, word number 2 VEC. And what it was a database where it's just like for every word, you got this vector, 2048 numbers. The positions of these values don't mean anything, but what it means is if 2 words have similar vectors by their kind of cosine between the vectors, the words have similar meaning. Well, really what it means is the words often occur in a similar context.
Okay. And this is, so this is a 2048 dimension space, and we're dot producting those vectors or something like that and looking for the
to find the angle. So what's interesting about it is they showed, okay, you take the vector for king, you subtract the vector for male from it, you add the vector for female to it, and you come up with a vector that's very close to queen.
Okay.
So there is some semantic embedding happening there.
Yes. It's not by an ontology, but, and how, I think, I mean, probably everybody sees where this is going. Let's just let the drama build for a moment.
Okay.
If I could ask a question, how does, in word to vec, how do we get those vectors? Like, I know the numbers are quote unquote meaningless, but you have to train something.
So it's essentially generating what's called the embedding layer for any neural net, like these large language models. Like all these neural nets that are large language models, ultimately the data feeding into it has to become some set of numbers that are feeding into the neural net. So you always have to figure out how you do this translation from whatever it is, an image, text, et cetera, to essentially a vector. And the way that Google would create this is it would do this thing where it's like, predict the missing word from a set of words, which could be ordered or it could be a bag. There's different ways to train it. Like, does the order of the words in your window matter when you're punching out a middle word and you're trying to predict it or not? But it, so I haven't dug into the details of how Google actually generates the vectors, other than knowing that these, it's a gradual tuning process. You train it on lots of data, and you train it such that if 2 words typically would occur in the same context based on the other words around it, their vectors are going to be similar.
Yes.
Close to each other. Right. So it just gets trained on lots of text with a set of words as context.
Right. And the, I guess, interesting point being, this is simply empirical. We've got text, we've observed it, we've trained, presumably this is a layer of neurons or something, and these are, I'm showing my deep knowledge of AI here, not
you go to
where the vector comes from. No, but we have this output, and it's just because we've looked around. We don't know what the words mean, but here's how
and you don't know what the values mean at each position in the vector. It's just a number.
That's inscrutable. Yeah.
Right. So the interesting thing, though, is for one of the client that I was really digging into this for, they're in the advertising space, and the words used in advertising space, the semantics, frequencies, et cetera, aren't like regular text if you're talking about web-based ads. So I needed to train our own set of vectors, like it was sort of specific training. And so I looked around and I found this Facebook research had this fast text open source project that generated vectors. They're smaller. They're 512 instead of 2048 values, but they had fast training, and I could easily embed it into our, at the time, Hadoop workflows, eventually Flink workflows. We could make that work. And then we did semantic search. But the first thing I ran into was, okay, how do you do fast vector search? Okay, so yes, I can take for a given ad, I can take all the words in the ad, I can add up the semantic vectors for each word and come up with a normalized vector that's the sum of all the word vectors for that ad. And now I got a vector, and I can find similar ads by doing find ads with vectors that are similar to this ad.
And these are you're describing this linear superposition of the parts of the sentence, and because they're vectors,
I just add the
linearity
vectors.
applies.
I can just add the vectors.
You can just freaking add them like they're just things. Yeah. Okay.
Right. And it's hard to do that fast, as I found out. So at the time, I'm like just, prehistoric caveman programmer. I'm like applying various heuristics to reduce the set of things that I need to linearly scan through. And I wound up with something that was good enough. But it made me interested.
It's hard to do the search fast, right? The
vector generation was fine. I could scale that out with, parallelism with big data, with a large scale workflow.
Now you've got a vector for the ad text, and you want to search against.
And I've got millions of ads, many millions of ads. So given this ad, let's find another ad that's similar, or even add all the ads for an advertiser. So here's a vector for the advertiser. Let's find a similar advertiser.
Okay. And so you happened upon this problem. If only I could search for vectors that are like this vector.
Right. And do it fast. And it's too big to fit in memory. So it's got to be, you got to be able to stream it off a disk and blah, blah, blah. Anyway, so I came up with something that worked, but it wasn't great. And so then I started, I saw that there were some techniques like this hierarchical small world, whatever, HSW approach, mumble. There's the last letter. I forget what it is.
Link in show notes.
Yeah.
Ken, send me a link to that later.
Yeah, I will. And it was this developer from, I don't know, Ukraine or someplace that was dealing with it was kind of like a physics problem doing fast vector search. And he came up with this approach for, sort of how you build an index on top of your vectors to make it faster to find nearby vectors, right? Because really what you're talking about is nearest neighbors. Like you don't ever have two vectors that are exactly the same. So what you're doing is trying to find the 10 vectors that are closest to it, right? So it's what they call a nearest neighbor search.
Okay.
And this one, the approach is like, well, you sort of randomly start out with like a set of vectors. And as you add vectors, you figure out which of your random initial set this vector is closest to, and you add it to that sort of group. And you can do subgroups. And so for a given vector, you say, okay, which one of these 10 is it closest to? It's this one. Now I'm in this area, and I can keep doing that till I get to, a small enough group that I could do like a linear scan through it effectively, right? So it's a way of subdividing the total space. And there's lots of approaches. There's projections to reduce dimensionality. There's anyway, but this one got implemented in Lucene for doing it as part of the Lucene project. And that made me think that, it'd be kind of cool to do this for Pinot, right? Because for my client, we do almost everything now using Pinot. We actually implemented a bunch of sort of the freeform text search stuff on top of Pinot. But we have this one weird thing, which is this vector search that's like that homegrown, whatever specialized thing. Wouldn't it be great to do that as part of Pinot as well?
So the shoe has dropped now. Here we are. We all knew where this was going. And I love this. Keep going.
So anyway, we started to explore that. And suddenly vector databases have exploded because it's all driven sort of by this idea of abstracting sort of search so that it's not just keyword driven. And there's a bunch of reasons for that. Because, for example, you could create semantic vectors across different languages. So I could do a thing where I'm like, here's my query in English. I turn it into a semantic vector, and now I can do a search in Japanese, and if I've aligned my semantic vectors, I can find documents in a different language that are similar to my English document.
Okay.
So, or, obviously fuzzy search. And a lot of times you'll see mixed approaches where you do semantic search maybe to find your top 100 best, and then maybe you use keyword-ish type approaches, BM25, whatever, to re-rank those because, there are some challenges with semantic search where the person's like, yeah, okay, no, I really wanted something a little more specific.
Okay.
Right. So semantic search lets you increase your recall in a way. It lets you find a lot more documents that might be relevant because you're not just depending on keyword matching. But you do have a problem with precision where the person's evaluation of the results that come back, they're like, well, actually, some of these guys, even though they're semantically equivalent, aren't what I'm interested in. And so by blending these two approaches, you can actually get better results, right? You do your initial throw the net out semantically, get a larger set, and then you re-rank using more traditional methods, and then you get your final set of results.
Okay.
If that makes sense.
So yeah, it does. So that's a large, fast semantic search, and the typical, database strategy you described a few minutes ago of getting it to something small enough that you can do the expensive thing, the expensive and accurate thing with it, small enough set of items.
So, so what's interesting about, this ChatGPT stuff is that back in the day at college, I was working on my thesis, and my advisor introduced me to this guy, Joseph Weizenbaum, who was also at the IBM.
Maybe you heard of him.
Maybe you've heard of him because of Eliza.
I was, by the way, if I just give me a minute, 8, 9-year-old little boy, liked to hang out at Radio Shack, TRS-80 at the front of the store, running Eliza. They're letting this little kid type on the computer. Mind blown. Yeah. So that's an important part of my early computing journey. I sort of knew this I need to be, and I've never touched AI my whole career. I mean, people, listeners who know AI well probably can tell from the kinds of questions I'm asking. Yeah, you really haven't spent much time here, but yes, Weizenbaum.
No, it's okay.
Eliza,
you want to be
very important.
Right. So it was really interesting. And that actually, one of our first programming projects at MIT was a Lisp version of Eliza, a very reduced version, but that was a project you had to do.
There you go.
And what was interesting talking to, so I talked to this guy, Joseph Weizenbaum, and he was saying how it scared him because people really loved their sessions with Eliza. And he's like, this thing, if you actually knew how it worked, it was so freaking simple. Just echoing words back, Rogerian, psychotherapy,
Which is perhaps more of a comment about Rogerian psychotherapy and talking therapies generally than AI technology, but that's a different podcast.
Yeah, but also it's something about people, how hearing people mirror back what you're saying is so empowering. And people were getting very upset that he was like shutting this thing down because it was freaking him out.
Okay.
Right? And it is so simple.
That's the thing, by the way, is that's I think the consensus of the kind of meta talking therapy discussion is you want to be friends and be seen by somebody, and that's kind of the magic. So yeah.
Right. So, probably the first really successful chatbot, which is interesting. Anyway, I just, to me, it was one of these things where I got the same issue when talking to video game designers, where they're like, often the simplest approaches give you the best results. Like if you're playing a video game and you've got these characters in the video game that you're competing against or interacting with, often it's very simple strategies for these characters that give you the best results versus like you can come up with these very complex strategies and they don't work very well.
There you go.
So, but what was also interesting about that is that I remember a friend, my best friend from college, business partner, he went to Jesuit high school and he had this thing called the Dogmatron in their yearbook. because they had to write theological papers. So you'd roll 3 dice, take the numbers, and come up with like the everlasting flame of the eternal whatever, and you could just drop it into your theology paper.
Okay,
if
so
you
sort
needed
of like systematic theology Mad Libs.
Yeah, exactly.
Okay.
So I was working at Apple Japan, and there was a sales guy there. I guess I can say his name, Fred Shearer, and he would always give us a hard time about talking technobabble. So I created this extension that I installed that when he was typing on his keyboard, about every 100 spaces, it would generate a like recursive heap compaction or acyclic graph analytics, and it would just type it into his document. And like about a week went by, and he came to me and he's like, "Ken, you got to help me. My computer's got a virus." It's like, "What are you talking about?" He's like, "Every so often I get this random text in my emails." I'm like, "Well, can you show me?" And so he's pounding away on the keyboard for like 5 minutes, but he's not hitting the space bar. So no random text. And I'm like, "Can't help you. Maybe you need to spend more time out of the office or something."
Yeah.
And he's like, "Look, this is killing me. You get rid of this, I'll take you out for, I don't know, Kobe beef dinner in Japan, which is super expensive." And I'm like, "I'll see what I can do, Fred." And, so that night I removed the extension and he took me out to dinner. And I've never told him that until this podcast. So there you go. Anyway, so generative text was very fun, even back in 1985 or 1986.
Yeah.
So, yeah.
I have a question. I know there's discussion within the community of Pinot developers, not the broader community of users, but even the community of developers about adding vector search to Pinot, people kicking the idea around. Is it valuable for vector search to be that fast, right? Pinot is Pinot because it does OLAP things with high concurrency, very low latency,
distributed
on very fresh data, distributed and scalable. Yeah.
Yep.
And everything's distributed and scalable, but what's the where's the pressure for vector search to be quote unquote real time? Which again, I threw the buzzwords out, so I'm being specific. Streaming data, lots of concurrent queries, crazy.
Thanks for bringing it home. No. This is good.
We're not headed home yet, but
no.
Why real time?
Yeah, I was kind of off in the weeds there with generative text.
Having fun.
All right. So here's a couple things. One is, how like people do a lot of stuff in spreadsheets that spreadsheets weren't meant for, like they're writing text, if you have a tool, it's great to be able to do the tool for lots of different things versus having to create other infrastructure, right?
Yes.
Okay. So given that vector search often includes other database-ish type things, right? So it's like, find me whatever. Let's say you're looking at, I don't know, the corporate filing documents in some data set, right? Find me companies similar to this company, but they have to be based in the US and their annual revenues need to be like in this range. So now I'm doing a filtering before I do my vector search, right? For our client, it's things like, well, find me ads that are similar to ads that contain the words, fast loans. Right. And so I've got to do a text query in this case, come up with a set of ads, get their vectors, maybe add them together, and then do a nearest neighbor search. Right. So it's not just vector search.
Okay.
Right. It's other database-ish things, which Pinot does really well in a distributed manner. So, scales. As far as the real-time aspect of it, I mean, it's kind of like when you talk about batch versus streaming. Almost everything that's batch would be better streaming. Like, everybody used to analyze log files as batch jobs using Hadoop. That was the dirty secret of Hadoop, right? Is that in the early, if you're talking about Hadoop stuff, 2010, 2012, probably, I feel like 95% of the cycles being spent in a Hadoop cluster were spent analyzing log files.
Okay.
Right? That's all done as a batch job, but it was only done as a batch job because that was the hammer that people had, the Hadoop hammer. It was batch.
You had a flathead screwdriver. You didn't have a chisel.
No.
And sometimes a flathead screwdriver is a chisel.
You can make it work, and they could, right? But really, in general, log data is streaming data.
It is, right? In fact, by nature, streaming data.
Streaming data.
And
so
you are better off knowing what's going on in the stream than in the batch. I think we all agree.
Right.
Yeah.
Right. I mean, streaming's harder on a lot of different aspects. It's harder than batch, but it's better. I mean, often, yes, you do have to process historic data. Like you want to load a bunch of historic data and then start streaming. Like time didn't start at the instant that you started running your workflow. There was stuff that happened previously. Right. So often you have that cold start issue of pulling in a bunch of batch data, but still it's better streaming. So I don't think like vector search as a streaming thing, like that's not an important sort of aspect to it. It's like if vector search is useful, then vector search in a stream friendly system is going to be better. Right. So
I think that is inarguable.
Right. Yeah. So I wasn't like, oh, Pinot does streaming well, ingest streaming data well. So great platform for vector search. It's Pinot is a scalable, distributed, fast, flexible, essentially analytics database. Vector search would be useful there. So.
And coming back around to your experience in the coffee shop, and the mini revolution that ChatGPT has kicked off.
Right.
Those technologies have all been sort of bubbling and forming for a few years, and now here's this thing, and it's a cultural phenomenon, and non-tech people care and are interested. And given that, now the growth edge of features that we're building and products we're conceiving of tend to be sort of similar to those capabilities, and you need vector search to get those done.
Right. And I mean, so even just talking about ChatGPT, right? Like I would love to be able to use ChatGPT to formulate my SQL queries for Pinot.
Sure.
Right? I need to
use it to formulate table descriptors. So yeah, right.
Yeah. But I mean, think about it. Like sometimes the queries, especially because, Pinot has some limitations around, sort of the multi-table join stuff. There's certain ways you can do it, but it's not full SQL, right?
Not yet.
Not yet. I know. Yeah. So like, I would love to be able to say, create this query for me as best you can, given here's my Pinot table and, the constraints of Pinot, what I can do, and just tell it, describe it, and have it come up with, well, here's your query. Like that would be a useful thing for ChatGPT in straight up Pinot environment.
Yes.
Or I don't know if you saw this, but there's a plugin not fully available yet where you give it a bunch of data. In this case, I think it's like in Pandas or maybe it's DuckDB or something. And you asked ChatGPT to extract insights from it. And it actually looks at your data and is like, I don't know, the example they had was like sales figures for electric vehicles in the state of Washington. And it's like, here's a graph that shows over time how it's shifted from this manufacturer to this manufacturer, like in terms of number of sales, and draws a nice little graph for you. So that, I think, is going to wind up being something you're going to see layered on top of a lot of these data storage systems, right? Your data's in various systems. You often are doing queries because you're asking questions of your data. When you're doing ad hoc stuff, like this isn't for dashboards, right? This is more like I'm exploring my data. Right. But wow, like that, I mean, whenever I was dealing with data, I would often load it into Solr or Elasticsearch, just put it somewhere where I could do queries. So I could say, find me unusually common values for this field, right? Some random field in there. And, show me the cardinality for that field. I'm like exploring it and I'm doing it manually, but ChatGPT could essentially automate a lot of that, help you understand the nature of your data.
Yeah.
And so I see that as something that's going to be built on top of a lot of systems like Pinot.
That would sort of be an application on top of Pinot, almost.
Right.
Query layer on top of the query layer.
Right. I imagine I could easily see there needing to be some things added to Pinot to make that efficient.
Okay.
You know, like in order for it to more quickly come up with insights. But yeah.
Sure. And vector search might be an example.
Might be one of them. Yep.
Might be one of those things. Okay.
Yep.
So it sounds like there's a Pinot feature there and a StarTree cloud application layer thing on there.
There you go. It's greenfield.
It really is. And that's, I mean, part of what I think is exciting about this, we discussed at the beginning, you know, there's hype, but then there's actually new, real exciting things that are useful and they unfortunately are indistinguishable for some period of their life. And the things that are useful, people actually get value out of them. And it's a whole reason for new investment, and new energy, and new enthusiasm. And that's a good thing.
A local guy I know is actually in charge of like dealing with all this stuff for a pretty major player in the hosted blog space. And we were talking about this yesterday, actually. I ran into him, or day before. The big challenge is staying on top of this. And what's interesting is I talked to a friend who's involved with Google, and he'd said Google views the biggest threat to them. It's not ChatGPT and OpenAI with the Microsoft investment. It's all of the open source stuff that's happening with generative text and large language models, et cetera. Like I get a newsletter once a week or so that's about what's happening in this space. And like every week, it's like, ooh, there's 5 really interesting things that could be game changers. It's hard to tell. Like reducing the training costs by 10x. If you could reduce the training costs by 10x, holy cow, you know?
You might need a few of those 10x's to get it out of the hands of the hyperscalers, but that 10x is always going to get everyone's attention. I
mean, I'm waiting for the SETI type thing to happen. Because more and more of people's laptops
mean like the
have
SETI screensaver from back in the day,
where it's processing radio signals to find signs of intelligent life and other planets. You could just say, go ahead, use spare cycles on my computer to do that, right? Well, all these people now are getting GPUs in their laptops. So would you like to support the training of open large language models that are publicly accessible? Great. Yeah.
While your laptop's plugged in, this thing will run. Yeah.
Yes. You know, because you're right. I mean, right now, to do these many billion, parameter models is a major investment. But you could democratize that. So,
and important implications for real-time analytics, important implications for Pinot, possibly things coming to Pinot. There's a lot to keep our eye on here. Thanks for kind of bringing me up to speed on it.
Sure. Happy to.
My guest today has been Ken Krugler. Ken, thanks for being a part of the Real-Time Analytics podcast again.
Thanks for having me back. It was fun.
And there you have it. If you feel compelled to help us spread the word and grow the real-time analytics community, you can give us a rating on Spotify or Apple Podcasts or wherever fine podcasts are sold. If you're watching us on YouTube, hey, subscribe and, of course, hit that notification bell. And you can always share your favorite episodes on LinkedIn or Twitter or wherever it is you do social media. Thanks, and I look forward to talking to you in the next episode.